Increasing complexity, higher compute performance, gigahertz clock frequencies, rising data rates, and fewer electronic control units, or ECUs, per car mean significant design, integration, and verification challenges for modern automotive ECUs. High-speed and high-frequency designs contain critical signals that need to be managed early on and require a transition from traditional PCB design to a high-speed PCB design methodology. Cadence Allegro PCB design and analysis tools provide a complete, integrated, simulation-driven solution for high-integration ECU designs. It enables PCB teams to simplify complex designs from concept to manufacturing. Analysis-driven designs help to quickly analyze the layout at any stage of the design cycle to detect and resolve potential SI and PI issues. Layout and routing algorithms make it easy to tackle both simple and complex routes in high-density designs. The constraint-driven environment provides real-time visual feedback and ensures the functionality and manufacturability of your PCBs and reduces design respins. Automotive ECUs can benefit from size and weight reduction when PCBs designed with Cadence Allegro tools are miniaturized with fine-line multi-layer and rigid flex substrates that can be folded and fitted into automotive housings that target specific voids and spaces within the car. Tight Allegro integration with mechanical CAD tools ensures productive electromechanical ECU co-design of housings and PCBs. Cadence PCB design solutions enable shorter, more predictable design cycles with higher component integration and system-level simulation for a constraint-driven flow. The result is highly accurate electromagnetic, power, thermal, and RF simulation analysis to ensure high-integration ECUs perform under wide-ranging operating conditions. Connect with Cadence to learn more.